this high-performance bus I was talking about, and it's connected to the CPU bus, wishbone bus with a bridge. Also, for generating these pictures that you see now, the FPGA directly drives digital to analog converters for generating the RGB component video. FPGA is only a digital component. You don't have any analog interfaces, so you need to add some external interface to generate the analog parts of the signals. And so the simplest way to do it is to connect a pure digital to analog converter to FPGA. Now, a few words about graphics acceleration inside the chip. It has acceleration for texture mapping unit. So texture mapping unit is what you are doing with your graphics cards. So you can distort an image any way you want. You also have a programmable floating point unit, which is a bit like a vertex shader inside your graphics card. And all this is highly flexible. You can implement milk drop or implement whatever computation you want, like, I don't know, just rotating a picture, or the compositing effects you like with KDE or whatever interface. You can also do it with these hardware components. The video inputs are still in development because I don't have any parallel TSC on this board, but so I need to make a custom PCB, and I didn't have time for it yet. So you could do live video mixing with video inputs. And also for controlling, I'm planning to use, as I told you, MIDI, DMX, and perhaps Ethernet for the open sound control protocol. So this enables the use of the device in artistic installations, performances, concerts, and whatever. So if you have if you want more information, you can get to this website. You will find the complete source code. Binary kits. If you have this development board, you can download the binary kit, and you don't have to install all the FPGA tools to get it running. You can just download the binary, and then you can change only the software. You will have a mailing list if you want to follow the development. You have wiki, blogs, and you can obviously find these slides. Just before we go to the questions, I will just show you a little demonstration of the system. So I'll just change the boot image name and reboot the board. Okay, now I will just throw the mid-drop preset. Okay, right now it's working. You don't see a lot of things, but yes, you see a little bit. So this is one of the sample mid-drop presets you can run. And right now this is running on the FPGA system on chip with hardware acceleration. So thank you for your attention.
Are there any questions?
Yes? It really depends. This board costs $500, but if you use a cheaper FPGA, because this uses a Virtex 4 FPGA from Xilinx, which is very expensive, and this board is a development board which is made in small quantities, and it has a lot of peripherals that I don't use, such as USB or whatever. It's also a very high-quality board with a very expensive PCB, which was, I don't remember, it was maybe 12 layers or something, because it's really made for high reliability. But if you make a cheaper design with for example, a Spartan FPGA, or and with less interfaces, it will cost a lot less than $500. Yes? Where do I buy the hardware? This board, you can buy it from Xilinx shop. You go to xilinx.com and you can find this board. But sorry. The question was, where do you buy the hardware? So you can find this board at, for example, a Xilinx web shop or any other electronics distributor. It's not very hard to find.
How does the silicon area compare to actually a real silicon if you implement not using FPGA but, well, real gates?
Sorry, I didn't get your question.
The amount of silicon area is much bigger if you use FPGA than if you have actually synthesized your own chip, right? So that also has a big impact on the cost.
You mean, is the FPGA more expensive than a real chip?
Yes.
Yes. Most of the cases, it depends on the volume. if you are, when you are making a chip, you have a very high engineering cost at the beginning to make the chip masks. This can go into millions of euros. And so you have to sell lots and lots of chips, and this cost get divided over all the chips you sell. But if you are only making a small volume, it's cheaper than using FPGA because FPGA has more or less a fixed cost. It's a cost per unit.
More questions? Oh.
On your license, it said eGPL. Do you want to explain that just briefly?
Yes, eGPL is a license to which you can define exceptions. For example, you can exclude militaries from using your design.
No more questions? There's time for still one question. And we'll carry on to the next speaker while he's setting up his equipment. Next speaker is Mr. Melvin Rook. He's about the multiverse. No, that was the multiverse project. No, the multiverse project is the next one up. No one here? Okay. While Mr. Melvin Rook is setting up the equipment, I have some announcement. There are some changes in the presentation programs. There is an iPhone talk at Monty Hall at 1900 hours that had been cancelled. So the iPhone talk 3.0, which was scheduled for 1900 hours tonight, has been cancelled, unfortunately. There will be a new talk at 2300 tonight about WikiLeaks. There will be a panel discussion about WikiLeaks again. This time it's in the Monty Hall venue, and there we will continue to have the discussions. Yeah. And at 1600, two talks have been switched in their location. Relaunch of Bits of Freedom will be in the 2 envelope stand. The 2 envelope stand is the third tent, which is on the other field. Yeah. And the Tempest for the casual electron hacker has been moved to Monty Hall. So please mark these changes in your booklets so you don't show up at the wrong presentation. May I introduce to Mr. Melvin Rook about the multiverse project. He's still setting up his microphone, so.